Good morning. This is lesson 8.4. We're going to be taking what we did the previous day on proving two triangles similar, and we're going to make an extension of that. So we're going to expand our proof here. Should be excited because this is the last one that we will do for the semester currently. Before we get into that, let's go with the classic joke. What did the 0 say to the 8? Nice belt. Got it. Moving on, let's look at example 1. We are given that this is a parallelogram, so we got to remember our parallelogram rules. We got angle 3 and angle 4 are congruent to each other, and we're trying to prove AB, this side here, times DF is going to equal HB times EF, okay? And this is basically the extension of proving the two triangles similar. So our goal would be to prove that this triangle, ABH, is going to be similar to EFB. Okay. And what is our favorite way of doing that? Angle-angle similarity. Currently, right now, we have two angles outside of them, but what do we know about 1 and 2? Good, they're the supplements of them, so we're going to be able to get the supplement pieces congruent, so we'll be able to end up with 1 being congruent to 2. And because it's a parallelogram, what do you know about a parallelogram? Alright, opposite sides are congruent, opposite sides are parallel, but we're looking for angles here. Yeah, I heard you. Opposite angles are congruent in a parallelogram. So now if 2 and 1 are congruent and E and A are congruent, now we know that these two triangles are similar. So let's start out with, if we had a parallelogram, A, C, E, G, alright. Reason 1, we can say that angle A is congruent to angle E. We got one out of the two angles. The second angle came from 3, was congruent to 4, which we can arrow out and say angle 1 is congruent to angle 2 because those are supplements of congruent angles are congruent. Bracketing these two together, we now just proved that triangle ABH is similar to triangle EFG. Right? That's what you did for last night's homework. That's what you did in the lesson the previous day. So now we're taking this extension. We're going to this piece right here. Okay? Well, that's where we're ending. So what we're going to do, this is how I like to do it, is to put a blank proportion here. Then put another arrow and finish what we need. AB times DF equaling HB times EF. Okay, because all this is the cross product of the proportions that you created from having the two similar triangles. Okay, and so if you don't want to mess this up, it's the same thing as how we go backwards. You remember with the 3x, you know, equaling 4y, and I said, oh, x is to y. Yes, that's right, 4. That's its cross product, and then 3 would go on the bottom because that's the x. We're going to be doing the same thing here, but we're going to be doing it in a proof. So what's happening is that I'll put AB first. That means AB's cross product has to be what? DF, which means that what's in triangle? We got HB being the cross product of EF. Ta-da! We're done. This isn't supposed to be challenging, but that's the best way of doing it, is proving they're similar, writing on this, and working your way backwards. So I'm going to write it here so you know it. Work backwards. Okay. Give our reasons. Well, the first one, reason 1 was if parallelogram, then opposite angles congruent. 2 was supplements of congruent angles are congruent. 3, angle similarity. 4, what's going to come after that is going to be definition of similar triangle. And 5, we're going to finish with the cross multiply. All right. So instead of like CPCTC, what we have is these two are going to come together, and they're going to come after your angle similarity, or your side similarity, or your side angle similarity. Hopefully that makes sense. It's just a little extension from what you did, but you're still going to have to prove the triangles by that. The second part of the lesson is now the stuff that you probably did 6th, 7th, 8th grade, where you had to find missing heights, missing shadow lengths, different things like that. So in example 2 here, if the trees were to fall towards the house, will it hit the house? Okay, here's the yard. The house is here. The tree is there. The distance from the tree to the house is 52 feet. Okay, so they didn't tell us how tall it is, but we have the similar triangle idea in the yard. So the bird bath stands 3 feet tall and casts a 2-foot shadow. So the bird bath is 3 feet tall, casts a 2-foot shadow. Okay. All right. Questions on that? Got this beautiful decorative bird bath. You get the splash in the water. Got the little birdie coming in. You know. So that's gorgeous. All right. And it's casting that 2-foot shadow. Over here, we don't know the height of the tree because that's what we want to know, because then it's going to be like if it's going to be able to hit the house. But what it casts is the shadow here. Okay, so we got this massive tree. We'll make it an apple tree. A little decoration. Okay. So, well, this is easy. You should be able to do this. Do you have to draw your own pictures? No, but I recommend it. It's fun. So what do we have? We have the 2-foot shadow matches with the 38-foot shadow. Equals, back to this one, 3 over h. Okay, you do have to keep, your units when you do it. So we got 2h is equal to 114. So we figured out that the height is 57 feet. That's what I'm talking about. Boom, for the tree. Will it hit the house? If it falls perfectly towards the house, like it's telling it is, yes, the tree will hit the house. Okay. So we're making that statement. Questions? No? All right. And last but not least, how long is the river? Okay. Well, I can tell you right now, they're not going to have you go across the river. You can see that what they do is, so if you ever see the people out surveying the area where they're outside and they're taking pictures across the way and they're checking out distances and they want to see if you can clearly see things and how far things are away, and they have laser levels and different things like that. That's what they do, because what you're not going to have is you're not going to be like, oh, let's measure this lake. So you're not going to get somebody that's going to come over here, get into their boat, okay, and they say, oh, okay, I'm in this boat. And they're like, okay, well, you hang on to the edge of this tape measure, okay, and then what you're going to do is you're going to go across the lake in the tape measure, and then you're going to hold it across the other side. One, because it's not a tape measure long enough, that's going to measure all the way across from there. So you're not going to have that too. Second, if I'm the other guy holding the tape measure on the other end while the guy's in the boat, you know what I mean? I like playing pranks, so whoops, I let the thing go. What's going to happen? That's going to come back, boom. It's going to leave him a mark. It's going to be like whack. So you don't want to do that. So we have to actually figure this out using mathematics, and that's what people do. So when we see this here, okay, I like to mark our angles, like I said, congruent first. So we know that these are vertical, so these two angles will be congruent, okay? Which means that these two angles will be congruent because they're right angles. I like drawing them separate, so those of you that want to be lazy and not draw them separate, you will get some wrong on the test, and it's only your fault that you will get them wrong. Like I said, draw them the same way, okay, meaning the angles match up. Now look at them. Across from this marker is 35, so 35 has to go here. Across from the double marker is 20, and I do not have anything there. Now having these, now it's a beautiful setup, because what do you end with? I have x is to 35 as, back to the triangle, 120, 150, sorry, is to 20. Cross multiply, 20x is equal to 5,250, which we solve. It is approximately 262 and a half feet long. I say approximately because certain parts have inlets and outlets. So, all right, so there's your lesson on 8.4. Good luck to you. Enjoy it. 8.5 will be coming up next. Ta-ta for now.